So today we're going to take our idea of functions and we're going to use function notation, and we're also going to see how to make tables from a function rule. So we're going to write a function table from a function rule, and we're also going to talk about independent and dependent variables. So there's a lot of vocabulary going on. The math isn't tough, guys. It's just understanding those new words, and we're going to take them a little at a time. So best attention. So remember that a function is a relation where every member of the domain is paired with exactly one member in the range. Now today we're going to go from, we've looked at mapping diagrams, we've looked at graphs, we've looked at tables as to whether something is a function. And today we're going to see a function in the form of an equation. So this is another way to express a function. It's called a function rule. Now notice in our last unit, we were solving equations and there was only one variable, and all of a sudden there are two in here because we're going to have an input variable that's going to represent our independent variable. We're going to get to choose what goes in there. And then we're going to have a dependent variable that kind of waits for the math to happen. So this little function right here, the m represents the amount of money I would earn, and the N represents the number of lawns that I would mow. So in the summer, let's say I mow one lawn. That means N would equal 1, and 20 times 1 would be 20, and I'd get $20. But what if I chose to mow more lawns? Like, what if I decided to mow 4 lawns? Then the N would be 4, and 20 times 4 would be $80. So the money would be $80. So depending on what value, what number I substitute in for N as to how many lawns I want to mow, my money will depend on how many lawns I choose to mow. So in this example, N was the independent variable, and think of that as an independent choice. You get to pick it. And then the M was the dependent variable, and think of that as the variable that's waiting for you to make that choice and waiting for the math to happen. So let's talk about what these two words mean. Now, we've heard them in science before. I mentioned them in the last video, but an independent variable, it's the variable that can change. Again, you pick it. Now, the dependent variable will be affected and will depend on what you pick. So the variable that is affected when that independent variable changes. So this guy's waiting for the math to happen, basically. So we're now going to start looking at these equations, as you see down here, very simple equations, but they're going to have two variables, and one is going to be an independent variable and one is going to be a dependent variable. The independent variable, you're going to get to choose how many. So in this case, the cost, C is the cost in dollars, and N is the number of music downloads. So if you kind of went out to iTunes or something like that and downloaded some songs, each one in this case would cost 99 cents. So if I only downloaded one song, 99 times 1, my cost would be 99 cents. If I downloaded 2 songs, 2 times 99 cents would be $1.98. So the cost can't happen until you decide how many songs you're going to download. So in this case, the number of songs that you download would be your choice, your independent variable, and the total cost would be the dependent variable, and it waits on your decision. So next, the equation D equals 4.5h represents the number of miles. So D is the number of miles that Amber can run, and H is the number of hours. So what is the independent and what is the dependent here? So how many hours Amber runs is her decision. That's your independent variable. Now, she runs 4.5 miles for every hour she runs. So the number of miles depends on how many hours that she runs. So miles would be her dependent variable. Let's take a look at the next one. This would be like a hockey game. And S is going to be the total game score. And G is going to be the goals in the final period. So as we get to the final period, this particular team already has 3 goals, and then they're going to add on whatever happens in the final period to get the final score. What is your independent variable and what is your dependent? In this case, the goals in that last period is the independent variable that when added to 3 will give you the dependent variable, which is the final score. So each of the dependents weights and depends on what happens to the independent variable. So I'm just going to take this chart. It's not in your book. Remember a second ago we were talking about the number of lawns mowed and getting $20. So this is called a function rule. And we're just going to go back through our vocab that we've been using recently. I'm going to add something new that we're going to talk about in a minute as well. But I'm going to kind of use the lawn mowed and the dollars earned, this one, as an example. So let's just talk about some words that go with the idea of an input. So an input would be your independent variable. It's what you choose to put in for that variable. In this case, it's the number of lawns mowed. That would be your independent variable. Well, what is the word that goes with the output that goes with independent variable? Did you think dependent variable? You're right. And that, again, that first case, that would be the dollars earned. Now we have some other words that can kind of go with that, but let's start first of all by realizing that the variable that we usually use in math, or often use, I should say, for the independent variable will be x, and the variable that we often use for the dependent will be y. That's from the graphing, an xy pair. That's why we use those variables. Now we're going to introduce another variable, which is going to be another name for y today, and it is called f of x. And that f, this isn't multiplication. It's not f times x. The f stands for the word function, so a function of x. And I'll explain more about that in a second. Now the question is, what is the name of all possible input values, all possible x's? What did we call that? Do you remember the name for that? And we've used it over the last couple of videos. Did anybody think domain? If the set of all possible inputs is called the domain, what is the set of all possible outputs? I'm hoping you thought range. And one way that you can also kind of remember domain versus range is domain gets tied with your x variable and range gets tied with your y, and everything's kind of alphabetical. So x comes before y in the alphabet and D comes before R. So domain goes with your x, your input, your independent variable, and range goes with your y, your dependent variable, your outputs. These are just our words again of domain and range. So we kind of have a nice graphic here that shows everything that kind of goes with our input and every kind of word that goes with our output. We still need to talk about him, so don't worry, that is coming. So let's take a look at the words a little bit more before we move on. Remember that the independent and dependent variables are connected. In the case of our lawn mowing, the money earned depends on the number of lawns mowed. That means that our dependent variable, the money earned, depends on the independent variable, which was the number of lawns mowed. Now, in this English here, the words depends on could be replaced as is a function of. So we could say that the dependent variable is a function of the independent variable. So the money earned is a function of the number of lawns mowed. It's just kind of a math English connection there. And if we get down to our variables, y is a function of x. Y depends on x. So here's some language between independent and dependent variables, and this is going to lead to a different way of writing this y. So before we go any further, I'm just going to show you kind of a little bit of a function box that's going to show how we are going to work with these function equations that I've been showing you. So let me just get out there and go ahead and show you this. So basically, a function takes an input value that you usually get to pick, it does some math on it, and the result, the output value, will be the dependent variable. So we're going to have a function rule, and it describes a function of math. So if you look here, this is going to be a function rule. This could be the letter y, or it could be the letters f of x, function of x. They are synonyms. It's like the name Mrs. W could be y, and Mrs. Woodruff could be f of x. They're two names for the same thing. So this is saying that there's going to be a function of x, there's going to be an input variable x. Whatever you pick to substitute in for x, you're going to multiply by 3, and then you're going to subtract 2. And the number that is the result of that math will be your output variable. So your input variable, you get to pick, what do I want to put in for x? We'll talk more about that in a second. And then once the math happens, there will be an output value. So let's just see if we can see a little bit of a picture. So x is going to be your input value. The function rule is going to take whatever you input for x, it's going to multiply it by 3, and then subtract 2, and then it will spit out an output, another number. So let's take a number, and let's say, what if we were to let x equal 5? That's my choice, my independent choice. So I'm going to let 5 go in and take the place of the x in the function rule. And so I'm going to take 3 times 5, which is 15, subtract 2, and 13 would be the output. So for an input of 5, so f of 5, the function value of 5 would be 13. This was my input, the 5, and this was my output, the 13. Let's take a look at another one. So let's take that same function rule, but this time let's pick a different value, a negative value. So this time I'm going to let x equal -3. So -3 is going to go in and take the place of the x this time. And I'm still going to multiply it by 3 and subtract 2, but of course, I'm going to get a different output. So in goes the -3. It takes the place of that x. 3 times -3 is -9, and -9 minus 2 is -11. So the function of -3 is -11. For an input of -3, I get an output of -11. So that's kind of what's going on with what we call kind of our function box. So just to kind of go over that again with some of the things I've been mentioning, in your book on page 288, here is a function rule. They're using f of x. It's read as function of x or f of x. It's not multiplication. And the x is going to be our input. You can put any real number. This is going to be our domain. And what comes out is going to be our range, just like we've been talking about. F of x is the dependent variable or the output, and it's just a different name for y. Well, why call it a different name? It is more descriptive because it shows you what number goes in, and we will see that as we move forward here. So here's an example. Here is my function rule. Let me just put a box around it. So let me just do this so you can see the function rule a little better. Okay, so there's the function rule. And what it is saying is we're going to take an input and we're going to multiply it by 2. And then we're going to add 1. And we're going to get an output. We're going to multiply it by 2 and add 1. So here is our function rule. So the question is, what number are we going to send into the machine, into the function? And this f of -3, this tells you what's going in. So this -3 is going to take the place of the x. See what it's going on down here. So f of -3, the function of -3, is to take 2 times -3, oh, by the way, -6, add it to 1, and you get -5. So when -3 went into this function, -5 came out. -3 is your input, -5 is your output. If we just wrote the variable y here, we would no longer see what went in. So that's kind of what's helpful with this f of x, this function notation. So there's a number that goes in for the independent variable, math happens, and then a number is outputted for the dependent variable. All right, so let's see if you can try this one. Now we got two chances here. So let's start with the first one. Your function rule is to take an input and subtract 4. It's easy math. Really, the math isn't tough here. What's tough is understanding what to do, right? So your function rule, how about if I do the box again? Here is the machine. Here is the function. Take an input and subtract 4. Well, my question is, what input? Will you see it? Okay, go ahead and try this one yourself. Okay, so did you replace the x with 2? 2 minus 4 is negative 2. So the answer here is negative 2. So the function of 2 equals negative 2. 2 went in, negative 2 came out. Okay, how about if you do the same thing down here? And again, I'm just going to help your eyes by kind of just putting a box around that function rule. Can you find f of 11? Oh dear, it's an odd number divided by 2. What's 1/2 of 11, right? So 1/2 of 11 would be 11 halves. Oh, by the way, 11 halves would be the whole number of 5.5. Or we could give it a common denominator here and add it, but 5.5 plus 5 is 10.5. Or 11.5 plus 10 over 2, which is 5, would be 21 halves. And 21 divided by 2 would get you directly to the 10.5. So when f of 11 goes in, 10.5 comes out. Oh, by the way, that would be the same as 10.5. And 11 divided by 2 would be 5.5. And 5.5 plus 5 would give you the 10.5. So there is a way to get there using decimals as well. So you can organize the input and the rule and output in what's called a function table. So we're going to have the domain be your independent variables and the range be your dependent variables. And then we kind of put the rule in the middle so we can kind of see what math we're going to do. So what we're going to do is we're not just going to put one value in. We want a bunch of values in. And again, you can kind of pick any ones you want, but you're going to see that there's a group of inputs that are going to become your favorites. And notice that here in the domain, they're putting -2, -1, 0, 1. I actually like to put 5 in. I'm going to talk about that in a second. Your book likes to do 4. But notice that they're doing 2 negatives and 0 and a positive. And you don't want to just put positive numbers in, because when you get to algebra next year, some interesting things can happen with certain function rules, and you need to catch it kind of on the negative side. So if you get in good habits right now of putting in some negatives, you're going to be a happy person later on. So basically what this question is asking is they want you to make a table of, in this case, 4 values of what's going to happen when you change this x, and you're going to put in -2. So you're going to find f of -2. You're going to find f of -1. You're going to find f of 0, and you're going to find f of 1. So you're going to do what we just did back over here, but you're going to do it 4 times using that same function rule. Just kind of like I did a second ago when I did the little factory example, and we put 2 different numbers in. So the first thing I'm going to do, and I could have picked -98, -40, 70, and a million too if I wanted to, but I'm going to pick numbers that are small, close to 0, because that's going to help me in the next video. So my favorites you're going to find are going to be the -2, the -1, 0, 1, and I also often will put 5 in, which would the number 2 in, which would be 5 inputs. So anyway, I'm going to put -2, add it to 5. -2 plus 5 is 3. So when -2 goes in, 3 will come out of this function rule. Now I'm going to change my input, and this time I'm going to put -1 in. -1, add it to 5, will give me a +4. When -1 goes in, 4 comes out. So f of -1 equals 4. Every time we're taking the input and increasing it by 5. So when we input 0 plus 5, we get 5. And when we input 1 plus 5, we get 6. Could we have picked 10? Sure, you would have gotten 15. Okay, but again, trust me when we say that these favorite numbers here are going to help you in the next section. So speaking of these favorite numbers, I usually like to do 5. I like 2 negatives and I like 2 positives. I love the number 0 when all of these are allowed to be put in. They're great choices. So my favorite 5 inputs are -2, -1, 0, 1, and 2. I call them the Fave 5. So here is a function rule, and let me once again put a box around it so you can see what we're doing. And in this function rule, any input you put in is going to be multiplied by 15. So the function of this rule is to take an input and times it by 15. What inputs? We're going to make a table, and you can pick any 5 numbers you want, but we're going to use, if they're not provided, our Fave 5, and they will be -2, -1, 0, 1, and 2. So I'm going to take 15 times -2. It's -30. Oh, by the way, a good thing happening to a bad person is a bad thing, right? 15 now times -1 would be -15. 15 times 0 is 0. Anything times 0 is 0. 15 times 1 is going to give me the 15 back. And 15 times 2 is going to be 30. Now, I'm warning you, the book usually just asks for 4 inputs, and they use these 4s a lot, or you can use these 4. But I do tend to, when I teach algebra, we talk about the Fave 5. 2 on the negative side, 2 on the positive side, and 0. So finally today, we're going to use all this information we've gotten, and we are going to make a function table for the function rule that takes an input and subtracts 7. So whatever number you're going to put into this function, it's going to take away 7. Okay, so they ask you to fill out the table, and in your book, it only has 4. You're going to notice I'm going to add a 5th one down here. And here are my Fave 5. I'm going to put -2 in, do the math. I'm going to put -1 in. I'm going to do the math and so forth. And then I'm going to name my domain and range. All right, so -2, take away 7. That's the math I'm going to do. And -2 minus 7 is going to give me -9. Now I'm going to put a different input in. -1, take away 7 is going to give me -8. Now notice these inputs are going up by 1 each time, and you're going to notice that your outputs will have a pattern if your inputs have a pattern. So 0 minus 7 is going to give you -7. And now I'm going to go up 1 over here from 0 to 1, and 1 minus 7 is going to be -6, and 2 minus 7 is going to be -5. So I made a function table, which is going to be really helpful when we do some graphing in the next video. Okay, we're going to go from here forward. But now before we go forward, let's look, what is our domain? Well, our domain that we chose was -2, -1, 0, 1, and 2. What's our range from that domain? Well, it's going to be -9, -8, -7, -6, and -5. So today we've gone a step further, and we have taken the idea of a function, and we have gone away from just mapping diagrams and sets and what we were doing in the last unit. And we're now seeing a function rule that has 2 variables, an input and an output. It's not really tough math. It's more just understanding what to do and the vocabulary really here, because once you have a function rule, you get to choose into the independent variable any values you want to create, let's say, a table. I have 5 favorites. The book often only has room for 4, but -2, -1, 0, 1, and 2. And one by one, and this is just workspace, I input each value in for X and do the math, just like putting it into a machine. And then I will have a number come out of the math. Your X is your input. It's your independent variable. It's your domain. Your f of x, or we could call it y, they are synonyms, they mean the same thing, will be your dependent variable, will be your output, and will be your range. And we're starting to head towards being able to graph what are called linear functions, and that's what we're going to do in our next video. So today, guys, we did a little bit more function work with some new words. When I see you next, we'll do some practice. Have a wonderful day, everybody.